I wanted to walk through the lab that you're doing that's due this coming Sunday because, as much as there's when a course is created, and I teach the courses that are created, sometimes information isn't always, we know that you have a book, we know you have a lab book. And when I teach my intro to networking class, which is separate from the Cisco stuff, because they take that before they take Cisco here where I am. Um, Sometimes there's so much information we want to impart to you that it can kind of get missed or just not within that scope. So I kind of wanted to back up because of one of the students that said, not sure exactly what to do, or not necessarily not what to do, but trying to figure out how to do this, especially this is your first level class and you haven't had a previous class to lead to this like we do here. So I've made this chart for you. And I've always provided this every term for my students, the cheat sheet, the CIDR cheat sheet for IPv4 addressing, which will help you. So I put that in here. But let's go ahead. I'm going to do this one right here. When you're looking at IPv4 addresses, we know that there are 4 octets, right? Because that's what the 10.101.99.17 is. There's 4 octets of 8 bits. It equals, when you add up, and this is what I use. You can do it the mathematical way. I'm not great in math, but in your book, it has where you're using the mathematical algorithm for it. Or we can use the golden chart. We call it the golden chart. It's something that you keep with you forever because it makes it, for me, faster and easier to do than trying to figure all that out. So when we look at the golden chart, when you add this up, it equals 255. And 255 is in your subnet mask addressing. This will always equate to, when you add 128 plus 64 plus 32 plus 60, if you look at it, it's really just doubling it. 18, 4, 2, and 1, it will equate to 255. All right, so we got that down. So when we break down addressing, either to decimal to binary, binary to decimal, that's another activity I have my students do. But when you do this, it makes it easier when you start breaking it down into binary and then be able to get to the subnet mask to get your CIDR notation. Then you can figure out your network addressing, whether it's going to be broadcast or unicast or those types of things. But for right now, we just want to be able to, here in this lab, identify what is the actual N capitalized with the 8 bits totally, meaning the ones are all on. And then smaller n is a bit in a portion of the octet. Okay. So when you look, I'm just going to start from the beginning. Let's just do it this way, make it easier. Here's our golden chart. And this is what we're using to break down into binary the addressing for IP. So we know our IP address is 10.101.99.17. We've already been provided the CIDR notation of 23. I call it CIDR, the CIDR, which equates to 255.255.254.0. That will be the subnet mask of this network. All right, so how do we do that? When we put our octets, when we break them down, like I have here, you'll see I've got 10 in the first octet. In binary, when we write this out, okay, 10, when we look at the chart, it's not going to be 128. It's not going to have 64. It's not going to have 32. It's not going to have 16. So those first 4 bits are going to be 0, right? Because the number is 10. Now we do see, the 5th one here, 8. Well, 8 will be part of it. So it will be on. So we will put a 1. 4, no, because 8 and 4 makes 12. So we'd be over. So that would be a 0. However, 8 plus 2 makes 10. Right? So, we're going to make that. Do I have too many here? 1, 2, 3, 4, 5, 6, 7, 8. Yeah, I did. I put an extra 0 in. Sorry about that. Here, let me take that out. Hey, there we go. So the first 4 are going to be 0 because 128 doesn't go into it. 64 doesn't go into 10. 32 doesn't go into 10. 16 doesn't go into 10, but 8 does. So it's going to be on. So we'll put a 1. 4, no, it takes it over. So it's going to be a 0. 2, yes, because 8 and 2 are 10. And then the last one, 1, would make it 11. So it's going to be a 0. So in binary, this first octet of 10 in the IP address is going to be 00001010. You got that. Now in the next one, let me break it down. This one here, 101. We'll see, okay, 128's over. So it's going to be a 0. However, 64 plus 32, okay, yeah, that would be 96. So those two are going to be on. So we'll put 1, 1. 16 and 96 takes it over. So nope, that's going to be off, right? And then 8, well, 8 could work, right? Or could it? So 8 plus 96, nope, going to take it over. So it's going to be 0. 96 and 4, though, equals 100, right? So it's going to be a 1 for that. However, if we do 100 plus 2, that's 102. It still takes us over. So that's going to be a 0. But if we do 1, there's our 101. So it's going to be 64, 32, 8, right? And 1. So 0, 1, 1, 0, 0, 1, 0, 1. Right? 64, 32, 4, and 1. All right. So that'll equate to 101 in our IP address. Now 99. All right. Well, we know it's not going to be 128. We know we're still going to use 64 and 32. So those two are going to be on. However, 16, 8, and 4 are all going to be off because it's going to take it over. So we're going to use 2 and 1. That will make 99 because this is 96, 97, 98, 99. Right? So we've got that one. Now the last one, this is pretty easy. Definitely not 128, definitely not 64, definitely not 32, but 16 would be in it because 17, okay, 16, that's less than 17. No, 8 isn't going to be in it. 4 is not going to be in it. 2 is not going to be in it, but 16 and 1 equals 17. So we've got 0, 0, 0, 1, 0, 0, 0, 1. So this is our IP address in binary, how the computer reads, how we work the network. Remember, 1s and 0s, that's how we communicate in a network with using computers and other devices. Now, when we want to break it down into binary for the subnet mask, well, we know it's 255. Well, what did I say about this? When you add all of these together, it's 255 because we have all 1s. Right? So 255, all 1s, all on. The next one is 255. All of those are on. The next one, though, is not all of them are on. Because remember, when we look here, we see, that we're looking for the network addressing part. Well, we've got a host in here. We've got a host listed because we know the sitter notation is 23. So there's a 0. So if that's the case, we don't have 255, we have 254. So the next one, notice it's all 0s. Well, if it's all 0s, that's the host. That's not part of the network address. The network address doesn't have the host. The network address has the network itself. So it's going to be 0. That's why you see 255, 255, 254, 0. And with that being said, think about it this way. When you see all 1s, it means that's part of the network address. When you see again, all 1s, that's part of the network address. And it's capitalized. There's no part and parcel of the host and the network being inside the same octet, is what I'm trying to say. That's where we get to the smaller. When I tell you here, a bit in the network portion of the address. Well, we know that we've got seven bits that are part of the network. But a host fell into this octet. So it's going to be all lowercase n's and a lowercase h. You have a mix like this, and that's what you have to pay attention to. If it's not going to be all 1s, it's not going to be all 0s. Okay, it's going to have part of it, part of a network in there. So if this was a bit different, and say you only had 5 of the lower end bits, and the rest were h's, small h's, because they are occupying the same space of that octet. Okay, so these, no problem. They're all uppercase. They're all network. All network. partial. We've got majority of it, but we've got a host also bleeding into this. And then here, it's very simple. This is all the host, meaning the devices. So when we look at the network addressing, then we're going to see that n.n for 10 and 101. And then we know a 99 has part of a host in there in the mix. So it's going to be 7 of the lowercase n's along with a lowercase h, because again, it's just a bit in the host portion of the address because they are occupying the same bit, these 8 bits together in this third octet. Now, if it was just all ones, then it would be a capital N. If it was all zeros, then it would be a capital H. And then you see there's your subnet mask, 255.255.0. Now you'll see that 10.101.98.0 is the network address. Well, because we have this host in here. So it's going to be one less. And the sitter notation, because they're supplying it to you already, will make it easier for you, because how you count it is you count, okay, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. And what's our CIDR notation? 23. That's how you find out what's the CIDR notation. And that's why I have this sheet for you. So when you go look at 23, 255.255.254 is the subnet mask. And what this means is that you could have 512 IP addresses allocated on this network. That means you can have 512 devices. That's what that means. 512 devices. And then we talk about class range here. Most of the time at home, we're on a C class, which is the 192.168 that we usually see. And then here at my work, we're on a B, which is the 172.12 or something. And then A. If you look, the range is, when you have an A class, you can have over 16 million networks. B, you can have over 65,000 networks. C, it's over, what is it? 2,000 something networks. And then D and E are experimental. We don't really use those. They're not for us. That's for development. So I'm kind of just doing this kind of quick, this part, because I'm going to try and get more into these things as I look to see what you're doing down the road to kind of help. But use this. I keep these. I've kept mine for years in a notebook, a cheat sheet for IPv4, as long as we have IPv4. And did I get it in there? Okay, maybe I cut it. I might have to put this in again, because I put it in your underneath the assignment where it says your assignments where the learning materials are, the content, the table of contents for module 5. I'll pull this up because I did this in landscape. So I'll pull this up so you can see how the subnetting works. But this is the notation. It goes 0 through 30. And when you see a slash 13, 14, 15, 21, this is simply what how many devices you'd be able to have in that network, that particular network. And then usually we end up segmenting them to make it easier to manage. The norm is usually about /24. Most of the places I've worked at, that means you're managing 256 devices, and you can have many different local area networks within your location. You're not just saying, that's it, you can only have 256 devices and you can never add to it. But this is how you break down IP addressing, IPv4 addressing. You use this, I use the golden chart. You can do it the mathematical way that you want in your book. It's fine. Either way, you're still going to get to the same place. But this, for me, makes it easier when I break it down. So when I look at an IP address, I'm looking here in the chart to get the binary for it, which will then lead me to my subnet mask, will then lead me to my network ID with the host. So this is the network ID. This part is not part of the network ID. We just want to know when we look at this, what's the network that we're on? Here you see 192.168.10, okay, is the network. The 0 it's the host. That has nothing to do with it. So this is the network. So any of the devices you add on that network They will be like 192.168.11, 192.168.12, 192.168.13, and so on as you keep adding devices. And when it says /24, like I was showing you here, can we see it? All right, 256. So that means for this network, we can have 256 devices on this network ID, 192.168.10. So 256 devices. They will vary. And in the 256 devices, you can break it down and segment it for your local area network to manage it. And on this one, we know that we have more than that, right? We have how many? Let me go back, 23, 512. If you look, it kind of just keeps doubling as you go, doubling as you go. Remember Gordon's, gosh, I'll remember it soon. It takes, sometimes I forget things and it's like, what was it I was thinking when we're talking about doubles? Yeah, so it's pretty much doubling. So your next one, you should be able to do the 209.165.200.227/27 and so on. You should be able to do this now. If you still can't, let me know. But remember, anything that lies within the octet, if they're together, if it I call it bleeding over. If there is more, if it's not just straight ones and it's not just straight zeros, if there's a combination, know that you're going to be using the lowercase because you're using some of the bits from networking and some of the bits from your host, meaning your device. Okay, so I'm going to get this posted for you. Hopefully this will help. And then I'll fix this so that where I had it, just so you know, I'm putting it right. I'm not putting it with your assignment. I'm putting it in the actual module for number 5. See, I have it right here underneath the module 5 assignments, right here underneath the whole area where you have your learning materials and my lecture. But I have it right here just below as a supplement to your assignment. Okay, so I will fix and make it so you can see it, make it a little smaller so you can see the cheat sheet. Okay. They just call it a cheat sheet. You're not cheating. It's just a cheat sheet. And there actually is online a location you can go to and put the information in and it'll figure it all out for you. Of course, you always have stuff like that. You don't have to use ChatGPT, but there is a place that will configure it all for you very quickly. But we don't do that here. We're utilizing and doing it ourselves. All right. So let me get this for you. So hopefully that clarifies. And anything else you want more clarification on, just let me know and I will work on that for you.